Hello and welcome to this demo of providing persisting data store using EMC XtremIO, Docker, ClusterHQ Flocker and Apache Mesos. In this demo we will fail over the MySQL container from one host to another while still reserving the persistent data residing on XtremIO. On the dark screen we can see the Marathon application, which basically provides clustering and HA services for containers. You can think of Marathon as the manager for containers. It's really useful when you're dealing with thousands and thousands of containers, and it's really the key foundation for orchestration containers as well. In our example, we can see that we have many applications starting with a suffix of test that are already running on our containers technology. In the Mesos tab, we can see that Marathon already dispatched the 7 applications that we've launched into 2 different hosts, LGSC113 and LGSC114. Each one of the 7 MySQL applications are currently hosted on a block device using the EMC XtremIO array. And if we actually run the Flocker driver, we will see those device names in a second. There you go. Now you can see all the application, and for example, if we copy a dataset name, we can then correlate it with the XtremIO array. So we just copy the name and paste it into the XtremIO site. So if we paste it, we can now see the volume that this MySQL volume is actually hosted on XtremIO. Because of the fact that it's just a volume on XtremIO, we can do many clever things around it. For example, we can add it to a consistency group, we can take a snapshot of that volume, we can present it to another host if that's what we wish to do, just like any other block device. Okay, now let's go back to Marathon and actually create an application. Press the create button, we'll give an application a new ID, just call it test220. We'll give it a minimum of memory, which is constrained by the application. In our case, it's 512 megabyte. We'll use the MySQL image. We'll use a bridge network setting. We'll use the internal container port that it will use, and then the host port, which is really the external port that I will use as a user to connect to the application from outside. We'll then use the driver. In our case, it's the Flocker, the ClusterHQ Flocker driver that we're using for persistent data. We'll give it a name. We select the variable and the path to that specific volume. And indeed, we can also call it with the external volume name. So here we're just going to select some specific MySQL parameters that are relevant for our application and press the create button. From that moment onward, it will send itself, Marathon will send the command, the orchestration command to Mesos, which will of course then in return use the ClusterHQ driver to not just create the application itself, but also of course to create the persistent volume on XtremIO. And indeed now, if we run the ls command, we will see the new volume that was just created for us. So in our case, it's this one, the 221. And of course we can query for that volume. If we copy its name and paste it back to the volume ID screen on XtremIO, there you go, we can see that it was created and even mapped to the LGSC114 host, which is in our case this host. And if we go to the host viewing tab, we can indeed see the initiator group and all the currently mapped volume that are mapped to that host. In our case, we're just using Docker and a container, so all of these volumes will have this specific volume ID. If we now run the same Flocker CTL command, we can indeed see that the volume has now been fully attached. So look at this volume using the new command. There you go. You can now see that it was actually attached. As you would expect, that's what the ClusterHQ Flocker driver does. And indeed, we can see the application itself is actually running inside of the container. So now we have a MySQL application running inside of a container. And indeed, we can all see it from here. From the Marathon tab, we can see the 220 is running. We can also go to the slaves view under Mesos and see that it is indeed running on host 1114. So we now have a MySQL up and running there. And again, back to the Marathon tab, we can see all the applications that are running. Now what we're going to do now is use a SQL Pro application to actually connect to the MySQL container to see indeed that there is an application running inside of that container. We're actually going to log into it and then even create a table inside the database itself. Give it the IP address, the name, the external port that we've specified before, if you recall, the one that allows me as a user to connect to from outside the internal networking. We can do a test connection and then eventually connect to that specific MySQL container. Okay, let's select the database itself. It will load all the tables that are created there. What we're going to do is actually open a table called engine_cost and create a new row that we will then use to see that indeed the data was failed over to another container, another host, but with the persistent data that we just created. Okay, there you go. We now have it up and running with the new table that we just created. So if you go back to it again, we can indeed see the table that we created. Let's even give it another row suffix, so the cost_name tab will have some meaningful data that we just put there. There you go, it's now been created. Okay, now let's actually go and kill the application itself. So indeed we can see the failover process. Remember, we are here simulating an HA event, killing the application inside the container itself in order to see that the persistent data still remain, even though we just killed the container, which would basically start on another host. So there you go, we can now see that Marathon declared this application as failed. And now let's look at some settings from the Flocker driver. So for example, we can now see that the application has been deattached from the host we killed it on, which is basically 46 was the one that it was running on, and 44 was the one that it's going to attach itself to. Same settings from here. You can see all the network setting, for example. Let's run the Docker command itself, see what values can be out of interest to us here. You can see all the application, which ports they are running on. Now let's run the Flocker syntaxctl command again. And indeed, we can now see that the application has been attached to host 44 from the 46 that it was before the failover itself. Now let's go ahead and actually connect to the new container that reside again on the same volume itself, this time just to a new host. Because we didn't do a network failover, just a data failover, we need to connect to it with a new port. That's expected. Those are behavior that you can basically designate when you're doing a failover, just demonstrating the data persistent failover in our case here. Okay, now let's select the database itself, go back to the engine cost table itself, and there you go. We can see that the row that we created, the dem_MySQL 220_v1_cost, still exists. So there you go. We can now see that the application still exists. Just jump to another host. We perform a true failover to another container while the data still remains. And that is the demo. Thank you very much for watching.